Models of the Rosetta spacecraft, Philae lander and Comet 67P in the foyer of the Max Planck Institute for Solar System Research in Germany are a constant reminder of the mission's success for many of those who work there. There's even a reminder outside the building too. Understandable perhaps, since 3 of Rosetta's science instrument teams, COSAC, COSIMA and OSIRIS, are based here. OSIRIS consisted of 2 cameras that sent back unforgettable images of the comet. While the operational mission ended in September 2016, ESA and NASA are working with the instrument teams to archive the highest quality data, ensuring Rosetta's legacy. At the same time, the science community is analysing this data. In doing so, they're discovering new aspects about the comet's behaviour, be it surface erosion, the transportation of dust, or geological processes, such as the appearance of fractures or craters.
I think the nicest discovery was when on our OSIRIS full team meeting, one of our colleagues was flipping 2 images, one before and one after image, and he said, "There's a crater," and that disappeared. And then we were looking at it, and then Holger said, "Wait, there's another crater that just appeared." So it was live when we were seeing the image. Somebody detected a change, and you really have to flip between images, and you really have to look very careful because some of them are very, very subtle.
Not all the changes were subtle. Outbursts of dust and gas caused the movement of enormous boulders across the surface, in this case by around 15 metres. And a recent scientific paper revealed a dramatic cliff collapse, exposing a shiny white material of, most likely, ice. Then, while analysing the data from the camera's final descent on board the Rosetta spacecraft, there was an unexpected surprise.
The last image transmitted from Rosetta was not the last. Was the last but one. It was the last that came down in one piece. And we see this elongated stretch over here. We are blurred, but we are at 80 meters above surface. It's really going down in warp speed now, and we get image by image higher in resolution and also we get sharp. And that's the last complete image that we shared at the day of landing, because this is what popped up on the screen. This is the last image of Rosetta, while this was the very last that we reconstructed from a few telemetry packets that we found on our service and said, wow, this could be an image there. So this is the last image of OSIRIS of Rosetta transferred to ground, reconstructed from the limited telemetry, so the few packets we have got. It's true size. It's 1 meter by 1 meter on the surface of our wonderful nucleus. So you can imagine this is true size. You can really grab the stuff on the surface. You can imagine your feet in here standing on the surface of our comet.
And all the data from Rosetta's instruments is helping to evolve our knowledge of cometary science.
We're going to refine our ideas of what the comet is, where the comet came from, and encapsulate that within our ideas of how the solar system formed. And the complexity of the data set that we have also allows us to be more complex in our ideas and our theories. And that is the beauty of Rosetta, and we're starting to see that happening now, that we're really able to hone down our ideas of how the comet formed, how that fits in the evolution of the solar system, and that's going to continue.